Assalamualaikum, my name is Nura Shazwani binti Sahari with metric number A69841 and I will explain for introduction and methodology. As for introduction, sound is categorized as analog data, which is continuous data. To analyze this data accurately and efficiently, we need to convert the data to digital form. This process is called ADC, which is analog to digital converter. Digital signal processing is where we manage the data after we convert the data to digital form. The behavior of this sound wave when converted to the digital form would explain the sound in our everyday life more accurately. Digital signal processor (DSP) digitize and mathematically transform real-world signal such as voice, audio, video, temperature, pressure and position. A DSP is made to quickly do mathematical function like add, subtract, multiply and divide. Signal must be processed in order for the information contained in them to be present, evaluate or change into a more useful signal. Sound is a signal because there is information in this vibration. Vibration communicate the content of the speaker message as they speak. In order to get the data for this experiment, Audacity application is used. Methodology, we have two different scenarios. Scenario 1, first step is two different audio is downloaded from the internet and transferred into Audacity. Second step, then the audio is streamed to only 30 seconds. Next step, phone speaker is used for this experiment. 4. Poco F1 mic is placed at the center of two speakers, which is at a distance 10 cm for the speaker. 5th, the downloaded audio is played at 30 volume intensity. 6. The audio is then recorded using the mic. 7. Step 1 and 2 is repeated using volume intensity of 50 and 70. 8. Step 1 to 4 is repeated using the other downloaded audio. 9. The recorded audio is then transferred into Audacity after converting the audio to AAC file type. 10. The maximum number of decibel and frequency of each data is recorded. Last one, data is then discussed. For scenario 2, first step is external microphone is attached to laptop through 3.5mm audio jack port. Second, Audacity software is open and smartphone volume is adjusted at 25%. Record button on Audacity was 3. Click at the smartphone and play sound at the same time. 4. The frequency graph is taken and recorded. The last step is repeat step 2 and 4 using a different level of volume.
Hello and Assalamualaikum. My name is Wise and my metric number is A168660. So I'm going to talk about the report result and data for experiment 1, which the main component is the volume level in dB and the frequency of the data. For each data, 6 main components are to be taken, which is the mean value, standard deviation, RMS, skewerness, kurtosis, and crest value. We run the experiment by comparing the audio that we record in low, medium, and high intensity volume with the original audio of the sound itself. From the data, what we observe is that the intensity of the volume will increase the value of the data that we gather. So for example, at low intensity of 30% of the volume, the mean recorded is -45.75, but increased to -41.725 at a high intensity of 70% volume. But it is also observed that the value of original data from the original volume is always higher than all the other recorded data. For the frequency data of our experiment, we can see an interesting pattern where from low to high intensity volume, all the data have the exact same value, except for the original, which slightly differ from the recorded value. But the rest, it all has the same value with each other.
Assalamualaikum. My name is Muhammad Ilmi bin Muhammad Fuzi and my number metric is A169377. So today I'm gonna talk about the result and data for experiment 2. In this experiment, we use different volume level which are 25%, 50%, 75% and 100%. So the result that we got for the decibel shows that the volume will affect the data that we want. For example, the mean will increase when the volume level increase, whereas the root mean square will decrease when the volume level decrease. As you can see in this table, it shows that at 35% volume level, the mean value is negative 66.34, while at 100% volume level, the mean value is negative 54.33. So, next, the frequency table, the value that we got shows that the volume level or the intensity does not affect the frequency. As you can see in the table, all values are the same.
Assalamualaikum and a very good day. My name is Fatina Syaizati binti Muhammad Nasir, matrix number of A166435. Today I will be presenting about discussion. From the data obtained, we are able to find out the values for mean, standard deviation, root mean squared, skewness, kurtosis, and crest factor. Skewness is defined as a measure of the symmetry in a distribution. A symmetrical data set will have a skewness equal to 0, which also indicates of a normal distribution. Kurtosis is defined as a measure of the combined sizes of the two tails. If the value is greater than positive 1, the distribution is too peak. Crest factor indicates how extreme the peaks are in a waveform. Crest factor 1 indicates no peaks, such as direct current or a square wave. From experiment 1, we found out that the frequency for all level of volume remains the same. The values for mean, standard deviation, root mean squared, skewness, kurtosis, and crest factor are constant. The value for the level becomes larger as the volume increases. When the speaker is in a normal state, it produces largest value for mean, RMS, kurtosis, and crest factor. The speaker is more dynamic, has the highest value for average continuous power that it can handle, and exhibit a normal distribution compared to the rest. When the speaker in high volume level state, it produces largest values for standard deviation and skewness. The speaker exhibits a moderate positive skewed data, which means that the tail on the right side of the distribution is longer or fatter, causes the values for mean and median to be greater than the mode. From experiment 2, we found out that the frequency for all level of volume remains the same. The values for mean, standard deviation, root mean squared, skewness, kurtosis, and crest factor are constant. When the speaker is at a volume level of 25%, the speaker produces largest value for RMS, skewness, crest factor, and it has the highest value for average continuous power that it can handle. The data is fairly symmetrical and it is more dynamic. When the speaker is at a volume level of maximum, which is 100%, it produces largest value of mean, standard deviation, and kurtosis. It exhibits flat distribution of data with a value of kurtosis at negative 1.651. But it is still considered acceptable for normal univariate distribution as it is somewhere between negative 2 and positive 2. In conclusion, the data obtained for both of experiments proven that those experiments were executed correctly as both of them have the same characteristics such as having a constant frequency value and flat distribution of data. Thank you.
Hello everyone. Here let's get to the last part of the project, which is the conclusion. My name is Jamil, and it is actually we are going to investigate the effects of variables on different statistical parameters of audio signal. As a conclusion, the values of mean, standard deviation, root mean square, skewness, kurtosis, crest factor for all levels of volume of an audio signal will be affected. Second, the input volume of the audio signal will affect the loudness of the audio sound as output. Third, when the speaker is in normal volume level, it is more dynamic, has the highest value for average continuous power that it can handle and exhibit a normal distribution compared with the rest. Fourth, the higher the amplitude power input, the louder the audio sound. Fifth, the frequency of the audio sound will also affect the pitch of the sound. Additional, when it comes to real life, the audio signal is actually an important signal to us. Actually, as in the advancement in digital audio technology, it has allowed us to have a very efficient and high quality speech processing algorithm in place. Second, these algorithms are applied in the process of recording, storing, and transmitting the audio content. It works on the principle of converting the audio signals between the analog and the digital formats, adjusting frequency ranges, removal of the unwanted noise, and adding audio effect to get a smooth and flawless speech quality.